আলাইকুম। আজকে আমরা যে বিষয়টি নিয়ে আলোচনা করব সেটি হচ্ছে ফুরিয়ার সিরিজের ডিরিচলেট কন্ডিশন এবং ফুরিয়ার ট্রান্সফর্ম সম্বন্ধে। সো ফার্স্ট অফ অল আমরা আসি ডিরিচলেট কন্ডিশনে। সো ডিরিচলেট কন্ডিশন হচ্ছে any function f of x can be developed as a Fourier series where a naught, a n and b n are constants are provided যদি আমাদের ডিরিচলেট কন্ডিশনগুলো ফিল আপ করে। So f of x is defined and single valued except possibly at a finite number of points in minus c to c range. So f of x is periodic outside minus c to c with periods to c. F of x and f prime of x are sectionally continuous in minus c to c. So আমরা দেখতে পাচ্ছি যদি ডিরিচলেট কন্ডিশনগুলো ফিল আপ করে তাহলে আমরা এই ফুরিয়ার সিরিজটা পাবো। Okay, then the Fourier series with coefficients n or bn converges to f of x if x is a point of continuity. Okay, what is the point of continuity? Where a point of continuity is a point where we find the real value of function. And f of x plus 0 plus x of x minus 0 divided by 2 if x is a point of discontinuity. Okay, then Fourier transform. Fourier transform is a mathematical transform that decomposes a function into its constituent frequencies. Okay, here we can see a complex values function. So Fourier transform of a function of time is a complex valued function of frequency whose magnitude represents the amount of that frequency present in the original function and whose argument is the phase offset of basic sinusoid in that frequency. So Fourier transform refers to both frequency domain representation and the mathematical operation that associates the frequency domain representation to a function of time. So here we can see the formula of Fourier transform. And it's the formula of Fourier transform and it's the formula of inverse Fourier transform. Okay, now we see the properties of Fourier transform. Here are different properties of Fourier transform. The first property is linearity. Okay, the linearity property shows that case if f of xt if after the Fourier transform if x of t converts to x of omega and y of t converts to y of omega, then the linearity property states that. So next, time shifting property. The time shifting property states that x of t minus t naught after Fourier transform it converts to e to the power minus j omega t naught x of omega. So we can see that this term x of t minus t naught is in the time domain representation and x of omega is in the frequency domain representation. Okay, the frequency shifting property is like that. We can see after that the time scaling property. Time scaling property states that x of at into 1 by a x of omega divided by a. Okay, the time reversal property. Time reversal property states that if x of t converts to x of omega after Fourier transform, then x of minus t converts to x of minus omega after Fourier transform. Okay, we can see the differentiation and integration properties also. We can see the situation of differentiation property here. When there is dt of x of t, then it converts to j of omega into x of omega. And here the integration property. Integration property states that integration of x of t dt after Fourier transform, it converts to 1 by j omega is x of omega. And next, multiplication and convolution properties. So we can get the product of two function here, and here the convolution property. Okay, so that's all for today. Thank you.